All right. Yeah, thank you everyone for being here. My name is Jordan Eldredge, and I work at Meta. I work on Relay, which is our open source sophisticated GraphQL client for JavaScript that includes web and React Native. And today I want to talk about semantic nullability, which is a rather opaque term. So maybe we could also think about it, if my slides will advance, as meaningful nullability, right? A null that actually means something in your business context. Or even more directly, nulls that mean null and not nulls that mean error. And so it's about finding this balance. Because today in GraphQL, there's a tension. Nulls in GraphQL are sort of intertwined with errors. And I'll get into why that is and what it is. Can someone maybe get the door? And, but it means that you're making this trade-off when you design your schema. If you define a field as nullable, that null can absorb errors, and you're getting resilience, which is super valuable. But if you're making fields null just to absorb errors, you're paying a cost in terms of ergonomics for authoring your product code, and your product developers are paying a cost there. Conversely, you can opt to make your fields non-nullable, but you're paying a cost in terms of resilience, but you're getting a gain in terms of your product velocity. And the one important challenge to note here is that often these costs and benefits accrue to different parts of the organization. Your server team may have SLAs around reliability, and your client teams may have objectives around how fast they want to ship. And that can complicate things in terms of making this trade-off as well. But what if there were a better way? What if we didn't have to make this trade-off? And this talk is basically the journey that I've been on for the last year and a half, sort of recreating that mental journey that I've been on to arrive at what myself and a number of other players in the ecosystem think is a viable alternative that avoids this trade-off and is available in some products already today. So let's do a review of how nullability and error handling are related in GraphQL today. So on our server, we have a type with a field called best friend. And in our system, users all have best friends. It's a really lovely system. Everyone's got a best friend. But of course, we fetch our best friends from our best friend service, and things happen. Our service might go down. But because we always expect to have a user, you can see here that this return type in the resolver is non-nullable. It's just a user. So when we go to schematize that, I think our first thought would be, well, we should represent that truth about our system in our schema, and we should mark it as non-nullable. The challenge comes in when errors occur. What if our BFF service goes down? Now, our GraphQL executor is in a great position to catch that error. This is a superpower of GraphQL, right? The executor has this meta execution layer, which is in a great position to catch that error. But we're not going to have a best friend user. We have an error. But also our schema says that if you have a best friend field, it's always going to have a user. So there's no valid best friend field we can return here. And GraphQL's solution to that is, well, since we can't represent the best friend field, we can't represent this object, and we're getting this ever-increasing blast radius from this one small error. Now let's imagine an alternative scenario where we've decided a nullable type could be used here. Again, our resolver errors, and we don't have a user to return, but now we do have something we can say. We can say the user is null. We don't have a user. Null is strictly type safe with regard to what we said in the schema. And we've gotten this really great advantage. We're able to preserve a whole lot of the response as part of that. And this is such a valuable trade-off to make that the GraphQL spec even has a best practices section where it recommends, let's default to nullable unless you have some other really good reason not to, because this resilience is such a valuable asset. So GraphQL can return null in the place of an error if it's type safe. And this is a really valuable thing in terms of resiliency, but it comes with a caveat, right? We've muddied what it means to get null back in our response. So now I work on Relay, a client framework. Now let's think about this muddy null from the perspective of a client engineer. And let's imagine that we're very diligent product engineers who really want to do the right thing. And we'll imagine a slightly different scenario where a different system where BFF is optional. Our best friend, not every user has a best friend in the system, at least not yet. But of course, our BFF system service might still go down. So obviously, we need to type this as nullable, right? It's a true fact that our system, some users don't have best friends. And now we go to write our product code. And we say, OK, we've got our best friend component. And if we don't have a best friend, we want to say, hey, my name is Jordan, and I'm looking for a best friend. But if we do have a best friend, we want to tell the world about who our best friend is. And this looks pretty straightforward, and I suspect this is what most product code looks like. But what happens if best friend errors? We're going to be telling the world that we don't have a best friend and that we're looking for one. And our existing best friend might see that and might get pretty upset with us. So that's not a great bug to have. So we're very diligent product engineers. And we say, well, what can we do about this? And so naturally, we go and read the spec top to bottom. And we learn that GraphQL not only will put null in the place of that error, but it will also include an error metadata in the response, including the path to the error that has occurred. Now, maybe we could find some way to intercept the response and go look at it as a product engineer. But really, as a product engineer, I'm expecting Relay, or my client, to be the interface between the data coming off the network and the data I consume in my product code. And so you go to your Relay team and you say, hey, I'm having a problem here. I need to know the difference between null and error. And we talked to a lot of users internally who were concerned about this. And we went through a lot of ideation about what we could do about it. And the first solution we came up with is, well, what if we could add a user, like a client-defined directive, catch, which would allow us to materialize that best friend field, not as just a nullable type, but in a richer type that can express these three states: error, null, and an actual value. And so with this directive, you can see that our best friend now is an object that includes an OK field. And if we check that OK field, and we've confirmed that it is in fact OK, now we're allowed, I've got some highlights here. Now we're allowed to access this value field. And TypeScript can ensure that we've first checked that it's OK before we access the real value. And so now our product code is correctly accounting for all three of these different cases: the error case, the null case, and the value case. But in a lot of cases, a best friend component might not really have anything sensible to render in the case that the best friend is in an error state. So maybe instead of returning, we would need to throw. And we say, look, there's really nothing we can do here. Now in React, that's actually a pretty OK thing to do, because React comes with a feature called error boundaries, which let you wrap subtrees of your UI to say if anything inside here throws, here's a fallback you can show to the user. Say, hey, something went wrong. We're containing the error to this part of the UI that's affected. Everything else can continue as normal. And you notice here we're being explicit about the error, right? We're being honest with the user that something is in an error case, and we're not creating this we're not flushing that muddiness all the way through to the user. But that pattern, right? We handled best friend could be in an error state, but maybe name could be in an error state too, technically. And maybe the best friend's name could be in an error state too. And now are we really going to handle 3 fields in 3 possible states and all the permutations of those? Maybe for best friend, if we think it's really likely that that service goes down, we know it's a flaky service, and we really want to have a granular handling of it. But really, our thesis is that maybe that's actually the best default behavior. And that at a fragment level, you might want to opt into that and say, I would like any of these fields that are in an error state to just throw. And now we're back to this original implementation where we just handle the null, and we're safe we're confident knowing that we're not going to misrepresent the state of that relationship in a way that could be, very damaging. So if we add this layer of client error handling, where we can contain errors by error boundaries, our runtime nulls, the values we encounter in our product code, are no longer muddy. They're the semantic nulls only. And that's really good in terms of correctness. And that was sort of the journey that we set out to solve for. And we thought, good job. But now, if we are in a world where clients can sort of by default handle those errors, and the product code is only ever going to see the semantic null value, the meaningful null, let's go revisit the decision making we did when we designed our schema for the non-nullable case. Right, we're back in this world, a happy world, where all users have best friends. And remember, we've decided to use nullable here so that we can absorb those errors. And as a product engineer, I'm still seeing this nullable field. And so obviously, I need to write the code that handles that null. That's all I can really see, right? The schema is supposed to capture for me all the information about what my schema or my server does and what the sort of domain modeling of this data is. And it's telling me it can be null. As a product engineer, I better handle that null and show something sensible. But we've got this throw on field error. So we're never going to encounter an error null. So what are we doing here? Like, why do we need that? Maybe we want to go look and we want someone to tell us, like, this thing is non-nullable. You don't really need to care about the error nulls. So maybe we could have like a comment in there to tell our users. They could go look at the schema and go, oh, you don't need, you just write an assert for that one because it's only null in the case of errors. You're already handling errors. Or maybe we could use a directive. And we could say, this is sort of our convention for how we tell the user this field will only be null in the case of an error. And otherwise, if you've handled the errors, you can count on it to be non-nullable. Well, now, what if Relay could understand that directive, or any client? It knows that you're throwing on field error. It knows the field is semantically non-null. The types that Relay can generate for this best friend field now don't have to include null. And it can just be, you can always expect there to be a best friend here. If we've gotten this far, if we haven't thrown, you can always expect there to be a best friend. And now we don't have to handle this null case anymore because it's already handled by the error handling. Now, I've given this example with one field, but of course, like I said earlier, really any of them could be in an error state and therefore probably nullable in your schema if you happen to be following that sort of best practice. And you might really need to handle all the different permutations of them, right? Okay, well, what if my name is missing, but my best friend is, I don't have a best friend, or I have a best friend, but my best friend's name is missing, but I don't have a name. If you are this very diligent product engineer, you really might be handling a lot of different permutations of what nullable means. But if we have this semantic non-null information in our schema, and our client is handling errors, we don't need any of that. I spent a lot of time on that transition. So to recap, we sort of understood how errors and nulls are interrelated in our schemas today in GraphQL. We examined how clients can be smarter about handling errors. And we then reflected that, well, if we have that error handling on the client and just a tiny bit more information in the schema, we can avoid a lot of the trade-offs that we currently have to make. So if our server can include the semantic non-null directive on fields that are only going to be null in the case of error, and if our client frameworks can handle errors, our products can become more resilient, can continue to be resilient in the case that you're already doing this best practice. We still are containing the errors. Writing product code becomes more ergonomic. We don't have to handle a lot of nulls that aren't useless, or that are useless. But also, our product code becomes more correct because we are not misrepresenting errors as nulls. And every null we get, we actually know we really need to handle it, and not just sort of like, it's probably never null. We'll just, something else. We'll sort of, show an empty string. It's probably fine. We're like, no, these are now real nulls that are semantically nullable as in our business context. And so we started in a world where these nullable and non-nullable were in tension across these two different domains. But with semantic non-null, we have a resolution to that tension. We can still have our resiliency and our ergonomics, our cake, eat it too. And it's more correct. And best of all, these features in this sort of this user-land implementation with this user-land directive are available today. Last Friday, Relay 18 shipped with the catch directive as I described it, with the throw on field error directive as I described it, and Relay's understanding of that semantic non-null directive in the schema. But this is not a Relay-only project. We think that this is can be an improvement to the GraphQL ecosystem. And we've had really great partnership with folks at Apollo, who similarly agree that this is a fruitful direction to explore. And they've added to Apollo Kotlin support for semantic non-null and catch. Caliban has added support for semantic non-null. And Grotz, which is a project I maintain for authoring TypeScript schemas or GraphQL schemas in TypeScript, has support for deriving semantic non-null. So just because the type is non-nullable, it'll automatically add that semantic non-null directive. So my ask of all of you here today, if this resonated with you, if this is a problem you do see in your organization, or a problem you didn't realize you had in your organization that now you realize you do have, is to try it out. If you use one of these tools, that's easy. You can just go try it today. If you don't use one of these tools, reach out to the people who work on that project. Maybe share this talk. See if they would be interested in doing the work to support this. This user-land implementation with a user-defined directive, we're sort of out in front of the spec. We want to explore the space and validate that this, understand what trade-offs may occur, what experiences people have, and if there are things that we don't fully understand yet. Because we hope that the future of this work is that it can be baked into the language itself. Benji has an excellent sort of pre-RFC that we're working on here. But we obviously need to be a lot more confident and a lot further along before we can bake this into the language, especially because right now it feels like it may be, there are a lot of trade-offs to be made with adding something this major to the language. So that's my whole talk. I just want to thank a number of people who are really instrumental in this work. I want to thank Itamar and Ryan, Itamar Kestenbaum and Ryan Holdren from Meta, who did considerable work on the implementation of the catch and throw on field error directives, to Joe Savona and Matt Mahoney, also at Meta, for reviewing early versions of these proposals, to Martine and Jeff at Apollo for their collaboration on bringing this to other clients and other tools, and to Benji for tireless work on helping us find ways that we navigate the path to hopefully bring this to the language. So that's all I have. I have no idea how I'm doing on time, but one of the very next talks is a panel on nullability. If you have questions that we don't get to here, you can scan this QR code and submit them as questions for the panel. But how much time do we have before the next talk? Oh, perfect. I was very fast. So I have time for questions. Oh, here.
Great, thank you. Do you already have something like, can we have extra metadata on like the errors? So if I want to communicate, for instance, that something is retryable, is that currently because it's user land reliant on extensions? Because it's, to me, it has always been a little bit awkward that we schematize things, but then errors go through this free-form thing.
Yeah, so at Meta, we have free-form errors, but we also do have some sort of structured errors. And our current plan internally is that we will allow those structured errors to go through. And this is like outside of the GraphQL spec, right? We're sort of deviating from the spec to put extra information in there. And our current plan is to allow product code to access those structured errors, but not give them access to the strings, lest untranslated, non-user-facing error messages end up in our product UIs. If you see one on Facebook.com, you can send me a message on Discord and complain to me.
Thanks. I didn't quite catch from your talk. If we have row and field error, then why do we additionally need semantic non-null if we want the field as non-null? We can handle the error with an error boundary, right?
Yes, so we're really left with sort of three types in the schema. And if you check out Benji's RFC, I think he does a very good job of communicating this sort of trio of types. There's non-nullable as it exists today with the bang, which has the effect of null bubbling. If there is an error, there's nothing it can do to show there. And then there's nullable, as we have today, which is like it can be null because it's a real null, or it could be null because it's an error null. And this semantic non-null provides like a middle path, which is it will only be null if it's an error. And so we need to sort of have that ability to communicate that middle thing. We're saying we're not going to, it's not always going to be non-nullable, but it will only be null in the case of error. And so that's why we need that additional metadata in the schema. Does that answer your question?
It still seems to be redundant. I understand the concept, the three different prongs of the
Yeah.
But if we have an error boundary, then, oh, I see. So the server will bomb out the entire query.
Exactly. So it allows us to decouple rather than doing the error handling in the data, which is destructive to what the client gets, it actually really follows GraphQL's mental model, which is to yield control to the client. So let the client decide what it wants to do in the case of errors. And we have now some tools to handle that in Relay. Other frameworks might offer different tools depending on how they're architected. But yeah, the idea is that we want to preserve as much data as possible in the response, and then let the client make up their mind, okay, because maybe it's different for every field. In my BFF component, maybe it's super important for me to have that BFF, but maybe in my profile, it's like, well, we can just omit that if they don't happen to have, if we don't know whether their best friend is there or not. And so this allows each individual consumer of that data to make the right decision for that component.
It sounds like a server-side error boundary.
Right, in GraphQL, the way the error boundary is necessarily implemented on the server because that's what the GraphQL spec describes, this communication between client and server. But there's real downsides to that. There are other downsides if you think about federation, if you think about, even in Relay, we have a normalized cache for data consistency. Anytime you're disrupting what data comes back, it can have all these knock-on effects in terms of other things that we're expecting that data. Maybe for the video. You could just come stand close to me, to my lapel mic.
Oh, here we go. So in terms of, I guess the server would be in the best position to sort of make the determination whether something is semantically non-nullable, or right? Because like if I know that there's, I don't know, no reason for this to, like, this isn't coming from potentially a microservice or something else, and it can only be null because I've made a business decision for it to be null, like that, the server would be in the driver's seat to kind of know whether that's the case or not. So as far as the client's concerned, it's sort of, the client doesn't have the full context in order to make this determination. I guess, sorry, to sort of boil it all down, what does this mean in terms of schema evolution?
Yes. So I think one of the big open questions is that nullability, sort of the major piece that we think about is error handling, but the other one is forward compatibility. Do we have the ability to deprecate this field in the future? And I think there's two angles to that. One, you can make that as an explicit decision. Just like in your server, you probably like define a method and you're like, ooh, if we're going to be migrating this thing pretty soon, like we should probably make this nullable so that like other services that are consuming this aren't dependent upon it. So it becomes a more intentional part of your design. So in the case of the type here, if we're always going to, for example, use this type as our guide for whether it's semantically non-nullable or not, we might opt to put a nullable type here because we anticipate that we may need to deprecate this field. But this is one of the things that I think we need feedback on because it doesn't feel like a solved problem to me. But the flip side of that is that I think as server engineers, we are a little too attracted to that idea that if a thing is nullable, we can safely deprecate it and not break things, right? In the case of this initial example, where if best friend is null, we're showing this message saying we're looking for a best friend, and we like deprecate that field, that's kind of still broken, right? And maybe we can pretend it's not because nothing shows up in our logs. It's just our users are having a bad experience. And then there are a lot of places where the nullability is just too much for product engineers to deal with. And they'll, look, I know this thing's never null. I'm just going to assert that it's not null, right? We see a lot of this. And so the reality is a lot messier than like, if it's null, I can deprecate it by starting to return null. And I think this starts to make that a bit more honest. So, but it's a trade-off that we're making. And I think we need more data from people using it in production over a period of time maybe to find out how that plays.
Thank you.
A kind of very related question to yours, and in a slightly different angle, is our choice of using directive, which we explicitly decided we're going to use the semantic non-null, the directive approach to show that this is actually non-null. And that means, right, if you put this on your schema, it is going to be a breaking change when our engineer decided to remove this directive. And I think it's a very unexpected thing for our GraphQL developers, because in general, the idea of removing a directive or adding a directive should not be a breaking change. So if we have thought of like other syntax instead of a directive approach, but yeah, this is basically building on top of your question.
Yeah, so like I said, this is a user-land implementation to allow us as a community to experiment with this functionality and answer questions like, what does this mean for forwards compatibility? Is that the right trade-off to make? Is it being explicit about errors? Sounds nice. Maybe it's not that nice, right? Like maybe our leadership would rather us just kind of launder those errors as bad UI and not own up to the fact that we're having them. And maybe it's fine. Maybe it's, in most cases, null and error are fine. So we need feedback on that. And so we're taking this user-land approach with semantic non-null as a stand-in for what we hope will eventually be syntax in the SDL. But obviously, syntax in the SDL is an enormous breaking, not necessarily breaking, but like maybe breaking, change. And figuring out how to add it is going to be very difficult. And we only want to take that step once we're very sure. So I think you can think of it as stand-in for syntax. And when we're in this middle period, we will have to be careful in how we think about it. Cool.
Do we have time for one more?
Yeah,
or?
one more.
Yeah. Do you think this is how non-nullable should behave by default?
Yes. I think if we were
Cool.
starting from scratch, with hindsight, obviously I think we got a lot from the trade-off we made, and I don't want to be dismissive of that. But now that we're in a place where we have mature clients who are in a position to do this error handling, I think, yeah, if we were to start from scratch, we would have two types. There'd be nullable and semantically non-nullable, and everything could be null as long as it had an error in the errors array, and we would expect the clients to manage that. I want to leave time for folks to get downstairs. Directly following this is a panel discussion on nullability, which you are now all experts in. And yeah, I just want to make sure we have time to traverse the elevators. And if you have questions, you can scan this QR code.